Alright, welcome to another video. Now, originally this video was meant to be all about the configuration of the IP leases and IP leases enablement on your provider. However, I've been researching and testing a lot, and with some help actually shout out to Markau from Palmito. He's actually pointed me into the right direction for this, so I'm sharing this with you now. There is actually a topology that allows for it allows that we use basically almost all IP addresses from an IP address block assigned by our ISP to the pods instead of wasting them on the nodes. The worker nodes actually do not need to be actually they don't even need to have an IP address in the public IP address block assigned to us by our ISP. So just hypothetically, let's say that our ISP has assigned to us 5550/29. So let me just make this bigger actually. How do I make this bigger? Like this. Okay. So this is 8 IP addresses. I explained this in last video. 2 to the power 3 is 8. So basically 8 IP addresses. However, we cannot use the first one. The first one is the network address. The last one is the broadcast address. We cannot use that one as well. And there is one more IP address we cannot use from this block, and that's 5551 because this device here, which is the firewall or the router, or whichever device you're using to actually route this block to, it has to have an IP address in this block. So for instance, up to here, our ISP has given us some way of accessing the internet, and then they are routing through this. They are routing this whole block, and the first address in the block cannot be used, and the first actually usable one needs to be assigned to this device. And usually you would want these devices down here to actually also have an IP address in this block, but and that's what I actually explained in the earlier video. However, it appears that we don't. So, and that's a good thing, because let's say we have a 3-node provider. If we had a 555 again 5550/29, in this case 5550 address cannot be used. 5551 is the router, and then we have 5552 and up to 5556. That's what we can use. .6. These are the available IP addresses, and 5557 is the broadcast. So this is the network. So yeah, something like that. And so basically our IP address budget is this, from 5552 up to 5556. And if we assign an IP address to each and every of these worker nodes, then it would look like this. This would be 5552, and then this one below would be 5553, and then this one below would be 5554, and what we're left with is basically only 5555 and 5556. Basically those are the only 2 addresses out of 8 addresses that we would be able to assign to the to our pods and basically lease them. So yeah, this topology, as I explained, does not require an IP address to be assigned here. It also doesn't require any separate network that I explained in the earlier video. I mean, the stuff that I did explain in the earlier video is still valid, but yeah, I think this is a much better way, and I think you will agree. So what do we have here? So we have another, so basically this this router right here has two connections. One, the first one, which is the classic Akash provider access network. Basically your Akash provider will be communicating through this link all the time with all the pods, with all your leases, everything. However, we have another link here which is being routed those 5555 addresses, 5550/29, and these IP addresses are they're incoming only. So basically, hypothetically, if we have a pod here, somebody has leased an IP address. They have leased, made a deployment with an IP lease, and they have leased, I don't know, 555. Okay, let's just say 5553. And if so, basically this address belongs to this here, this link right here. And this pod, if you go out in any way, if this pod needs to communicate with the world, it will actually go this way. It will not go this way. It will go this way. So this is the reason why, if we try and figure out which IP address we actually did get, it doesn't work. Perhaps you've noticed that, perhaps you haven't. However, if we go to a site like checkip.dns.org, this website will basically tell us which IP address we're using right now, and if we go and check, do a curl check IP DNS.org, we will actually get this. We'll get this IP address and not this. The only way we will be using this is for incoming connections. That's all. So basically, if you're sitting somewhere outside and you want to, I don't know, you have enabled SSH access to your pod, and then you SSH to, I don't know, 5553, you will actually get a response. You will get to this pod and it will respond, and this connection will be established. Now, how this works is basically without a gateway. You will see later during the configuration phase, we don't specify this, which is 5551. This interface right here has a 5551 IP address. It actually has two IP addresses. Yeah, it has the standard, I don't know, whichever one you decided to use, 192.168.10, I don't know, 10.20 for instance, /24. This is kind of the standard local IP address space that you would use. And besides that, this interface can also have 5551. That's normal. I mean, normal. That's quite a common networking practice. You can assign multiple addresses to a single interface, and you can have more than one IP address block on the same broadcast domain. So that's also something that's quite common in networking. So yeah, basically how this actually works, and how does this pod know how to get out, basically without a gateway in this block, is because when a packet arrives destined to 5553, which is this pod right here, it will actually get routed up to 5551, and then 5551 will issue an ARP, ARP request. ARP means address resolution protocol. Basically what this does is, that's also standard networking stuff in IP version 4. IP version 6 doesn't have ARP, but IP version 4 does. And what it does is basically, since 5553 is in the same broadcast domain or in the same IP address block as this IP address, it will issue the ARP request requesting the MAC address of the 5553, and this pod will respond. So this pod will say, hey, I have a 5553, and it will respond to 5551, and then the communication between these two will start. And the all incoming traffic will work. However, outgoing traffic, since we have no gateway on this network, all the outgoing traffic will be going out. So basically, when I say incoming, it means that it's initiated from the outside. And if we initiate a connection from the inside, for instance, we want to do an apt get update, which is a standard you want to command, we will actually be using this. Okay, so I hope I didn't complicate this too much, and I hope you have understood this. Basically, it simplifies things, even though it looks as if it's more complicated, but it's actually more simple. The only concept you need to understand is that you can have more than one IP address on a single interface. So basically that's that. Okay, time for configuration. All right, so let's start. The prerequisite for this, basically, you will not be able to do anything without a working Akash provider. And the Akash provider has to be built on with Helm charts and not with Praetor. Sadly, I'm sure that the Praetor guys are working on the IP leases as well, but for now it's only available for Helm charts builds. So basically, if we go to the official Akash documentation, if you click on providers and build a cloud provider, this is the part that you need to. These steps are the what you need to actually have working. Basically, your provider has to respond to queries. So this is the RPC node. You also need actually, yeah, definitely. I mean, that kind of goes without saying. You have to have a working Akash node. But yeah, I didn't think that it was necessary to to say that. Basically, your provider has to respond, and you should have it. If you check and try and deploy something, you should be able to successfully deploy, and at that point you can start with this procedure that I will explain here. So basically, click on the IP leases and provider enablement. Okay, we need to add this part to our provider.yaml. I will not show you what my provider.yaml looks like, but I will copy this and cd provider. Actually, let's go to another window. After you have done that and added this to the bottom of your provider.yaml, again, I won't be showing you because there's some sensitive information. So yeah, basically we need to do a Helm upgrade. So here we go. Set the important part here is set IP operator to be true. This is exactly what the output that we have gotten. Now we need to install the Akash IP operator, copy this command, paste it here, and I need to add my own address. Okay, so I need to enter my own address here, which is this one here. That's the address, the Akash provider address, and that's that. Okay, next we need to create the MetalLB namespace. That's what MetalLB requires. MetalLB is the it's basically the load balancer and the package that this whole feature is basically based upon, and we need to install the MetalLB. So copy and paste these commands, and that's that. Now the last, basically one of the last steps is you want to copy this part here and paste it in some of your in one of your text editors, yeah, because what you need to do is basically make sure that these addresses actually belong to you and that they are routed to you. Now these bottom ones are actually the ones that we're going to be using, as well as the 218. So yeah, that's what we're going to be using. So basically copy this whole thing, like all of it, and then edit, and then when you're done, paste it in your right here, and then I think that let's remove the Helm stuff so that there's less clutter. The deploy.yaml will be created, I believe. No. Sorry, that's not it. Okay, and no, that part will come later. Okay, and we need to okay. And last thing is, I think we're done actually. kubekettle get pods .a-a. So we have the Akash IP operator, and we have the MetalLB controller and MetalLB speaker. I think that this part is actually, no, we don't need that right now. I think we're actually done. Let's yeah, the IP operator is not yet ready, so last thing basically that we need to do is restart the provider pod, because it's not aware that basically, yeah, we need to delete it, go back. Let's watch as the provider pod gets updated. And that's that. I think IP operator is not yet alive. Okay, let's IP operator. Okay, it's gonna get restarted. let's see, what did we miss? Ah, we didn't expose it. This is what we have missed. Okay. We have done this part. Here we go. Wrong command. Here we go. It's exposed, and I believe that we need to restart the provider pod now. So this is the time when we actually restart pod. That's, I mean, what you have witnessed here is classic Akash provider troubleshooting. So yeah, I think I've actually let this be visible so that you can all basically see it's not yet alive. Okay, one more time, let's restart the IP operator. Okay, it should come online now. Okay, let's see. Get pods -a, all of them are running. Let's try and deploy something. Oh, here we go. Okay, good. Seems to be working. So let's try and deploy something. I'm gonna try and deploy an Ubuntu leases, a Ubuntu server with IP leases. So deposit, I'm not showing you this part, but you will see here in the here we go, submitting for fulfillment. It's gonna bid now. Bid complete. I should be able to see it here. Okay, let's give it a moment. Interesting, I'm not seeing a bid. Let's try one more time. Let's actually see if yeah, the provider is not, the CloudMOS doesn't see the provider, that's the problem. So when you restart when you restart your provider service, or when your provider is down for a long time, then the cloudmos.io will actually not see it for a while. So all you need to do is basically just wait for the cloudmos.io to pick up that there actually is a provider working. And yeah, we'll come back a bit later to this. Okay, that's finally done. Now we can see the bid. So let me make another bid. Oh, actually another order. Okay. Here we go. Submitting fulfillment. We we should see a bit complete soon. Here we go, and I should be able. Here we go. We can see it. We're gonna accept it. I'm not showing you what's going on here, but you will see what's going on here. This is the important part. Here we go. Okay, deployment complete. Okay, we have received an IP address and we need to wait for the pod to actually start, and then we'll be able to log in. Again, I'm not showing you what's going on in the CloudMos deploy. That might actually be interesting, but the important part is going on here. So what we will do is open up another window here and wait for this to actually start. Ping 194.28.28. 218, and it's already up. This is the response from the pod itself. So it's still not fully up. Let's try an SSH. SSH root at. Of course, I already did this, so the signature is invalid. Yes. Type in your password, and here we go. So note this. Let me show you now what I was talking about earlier. This is the IP address that we actually received from the provider, and this is the IP address that I've used. Let me actually exit and show you again. So I'm SSHing into this using this IP address as the destination. However, I don't know if this has curl. Oh, it does. So curl HTTP check IP DNS.org. Note that this is the IP address that the pod is actually. So when I, for instance, type ping google.com, we don't have ping, but whatever. I was using this curl command. So I was initiating a connection from inside the pod. As I was explaining earlier, all of these connections that are initiated from inside the pod will actually go out through this IP address. That's actually a better way to say it. It will use this IP address as the source IP address. However, incoming traffic will be you can use the IP address that you have been given when you leased it. So basically, but if we type IP address, we cannot see this address. Yeah, that's kind of counterintuitive. However, the IP address operator that's being installed on your provider is actually doing the forwarding of the traffic to this pod. So this pod actually is not aware itself that it has an IP address of 194.28.98.218. So this is the IP address that we used to connect. So yeah, there you go. I hope I've explained it. I hope I haven't been too much of I haven't complicated it too much. If you have any questions, please don't hesitate to ask. Type them in the comments below, or ask them in the official Akash Discord. Shout out to Markau one more time for helping me set this up. I mean, all he did was point me into the right direction, and I basically managed to figure this out after that. But yeah, these advices are yeah, they're worth their weight in gold, basically. So thank you one more time. Shout out to my buddies at Akash, the core team, the vanguards, the insiders, and yeah, see you in the next one.